I'm Russ Kickle. On this episode of American Reef, I'm going to teach you how you can take a solar panel, a Tunze Turbelle, add a few parts to it, and basically outlast any power outage, be it a minute, an hour, a day, a week, and we could even do it a month if we wanted to size this thing that way. We're going to do that and more on this episode of American Reef. So before we get started, right, why do we even care, right? Why do we want to outlast any kind of power outage? Well, for you new hobbyists out there, you know, obviously you have an investment in your fish tank, right? So you have fish and coral, for example, that ultimately need oxygen to live, right? If they don't get that oxygen, then they die. It's that simple. And when you look at it, when you have like a saltwater or a coral reef tank, you know, it's not only the fish that need the oxygen, it's not only the coral that need the oxygen, it's not only the, you know, little crustaceans that need the oxygen, the bacteria that we use for filtration also need the oxygen. So you need that water to air exchange, right? And the best way to get that is with circulation, right? And that's why when I said that a turbelle, that's what I'm referring to, meaning that if we have power to this thing, we can keep water circulating, and then from there, it will basically allow that oxygenation, to take place. Now, there's a lot of other things that we're going to need, right, to kind of address power outages and things of that nature. However, this is a nice place to start because this by far is the first thing we have to figure out how to take care of. Now, as you're thinking about providing oxygen to your fish tank, for example, think of it in two parts, right? You have fish, corals, and the organisms in the main display. And if you have a refugium, for example, that has whatever kind of macrofauna, you know, maybe the biospheres, for example, you know, things containing that living bacteria, that's another area that we're going to need to make sure we aerate, or we make sure we get a lot of oxygen to them. So again, that's why I really like this kind of Tunze Turbelle kind of solution, because you can get little pumps, right, that hardly draw any wattage, and you know, you can provide a lot of options to get that kind of circulation going. So let's talk about that a bit. So now with the turbelle, how do we hook a turbelle up to a solar panel, right? Well, it really all starts with a little safety connector. Now when you look at this one, this is the Tunze 6105.50 safety connector. And when you look at it, it's really simple. The main function of this thing is to basically take two power supplies, right? And when one power supply goes out, basically alternate the power supply to another source. And it's that simple. So the idea when you have main power coming in through here, basically it's going and it's supplying, you know, and you can see the labels here, it's supplying the power to the pump. Well, when this power goes out, and if we watch over here, watch what happens. All right? It still goes on because I've got these two little lantern batteries hooked up to it. So when you look at it, now it's drawing the power from over here, but we never missed a beat. The circulation is still happening. Plug it back in, or your power comes back on, and ultimately you know, it's drawing power from your, you know, your wall power source again. So when you look at it, this is really, you know, kind of the brains of the whole operation. Now, you know, I look at these things and it's really funny because for something this small, right, to enable the kind of transaction that really takes place, you would think that is relatively expensive, but I found it's actually the opposite. Meaning, you know, it's probably somewhere in the neighborhood of, you know, 55, 60 bucks, something like that. And though $55, $60 is you know, again, not money that you want to throw away, right? I mean, for me, I look at $55, $60 as kind of like 3, 4 pizzas, right? And as you can tell, I like my pizza. However, that being said, this is one of those things where it's a pretty good investment of that 55, 60 bucks. And, you know, so let's talk about that for a second. So we have this unit, right? Again, the safety connector. Well, what can we hook up to it, right? What kind of power supply options do we have? Well, that's where it kind of gets, you know, it's all up to your imagination, right? Like in this little example that I have set here, I have 2 lantern batteries. Right? And let me take a second kind of show you how these are hooked up so it'll kind of describe or maybe make it a little clearer for you how this safety connector actually works. So when you first look at the safety connector, basically you see your 3 kind of wires hanging from it. Well, again, relatively simple. You have power coming in, so this is again from your outlet. You have right here another power source where you can see where it's basically 12-volt battery, 1224, and then you have a connection to your pump. So when you look at it, what's at the end of this battery source, for example, if we trace these wires, right, that will get us to a junction box. Now when you see this junction, again, it's something that we've seen before, but basically it just takes and will connect 2 wires together. Now, when you look at it, all that's doing then is it's taking these wires over into these 2, again, lantern batteries, the 6-volt. Now you need 12 volt to run this thing, so that's why you need 2 of them. Now, you know, how do you get 12 out of, you know, 2 6s? Well, you just run them in series. To do that, you're basically going to take a clip, right? You're going to connect a negative and a positive together, and then from there, you have your positive and negative that will actually supply the power, again, through, you know, you can use something as simple as the speaker wire, again, which takes it back to the safety connector. Again, the joy, you pull it out and it automatically takes care of things. Right, now it's drawing power from the 2 batteries. Now, the thing that I really like about this is it's relatively simple, meaning there's no computers involved, right? Because those of us who have had Apex controllers before, or, you know, ReefKeeper, for example, whoever, you know, whatever technology you want, anytime you have computers involved, there are glitches. For whatever reason, there are glitches. And, you know, right here, right, the only glitch that I've seen is basically something provides too much power to it and the fuse breaks. You know, so when you look at it from a fuse perspective, it's like every other fuse that we've got. You can take this thing here, if you look at it, if you just press down, twist it up, and you can kind of see how the power stops now because it doesn't have any power. But, you know, a bag of these fuses costs $4, something like that. But again, you can put it back in like this, push back down, and look what you have, right? You've got your power. So when you look at something like that, as you can see, it's a little bit of a DIY kind of project. But, you know, A, it's not that expensive, right? Meaning, you know, one of these connectors, again, was that 55 bucks. You know, some speaker wire and some clips, where you got $5 into that, you know, and then, you know, the lantern batteries. When you look at the lantern batteries, again, they're what, $6, $7, something like that. You can get them anywhere, right? And, you know, you put them on your shelf. They last probably 7 years, that sort of thing. So when you look at it, you know, it's relatively simple and easy, and you got a great backup source, one that can last, you know, for, again, for as much money as you want to spend the batteries. Like, I believe these 2 batteries will probably push this 6095 for probably about 1.5 to 2 hours, something like that. And depending on, you know, how you're running it, that sort of thing, you could probably extend it longer. But it really, you know, when you look at it, it's probably a good guesstimate of where you're at. So again, if you want 24 hours, for example, buy yourself 48 batteries. Now, you know, when you're looking at it that way, well, 48 batteries, okay. Again, though you can get these kind of batteries anywhere, you know, 48 batteries is probably a bad choice, right? But, you know, now what you can do is think of, okay, now what can I do to kind of change the battery out, right? And that's where, if we look at this, you know, we could go with, you know, those kind of batteries, for example, that will ride, or excuse me, that provides power to kind of like those Power Wheel toys that your kids got. You know, they're called SLA batteries. I believe it's called sealed lead acid batteries. Give me a second and I'll go get one, and you'll see where I'm getting at. I just grabbed an SLA battery, for example, and when you look at this one, for example, this is 8 amp hours. So, first of all, you can see the size, right? It's probably about the same size as the two, you know, lantern batteries. And this right here, though, will probably last you around, we'll say, 8 hours, right? Again, I think for the 6095, I think Roger had said that for every amp hour that you get out of here, right, will basically power a 6095 for about an hour. So now when you think about it, okay, one of these batteries costs like 50 bucks, for example. Well, so we've got 8 hours out of here versus to get 8 hours out of here, again, you would need what? How many batteries? Somewhere in the neighborhood of 4, right? 4 sets. So now you can see the math, and you know, again, the math works better on these. Now the thing about it is, these are rechargeable. So these are one time, you chuck them. This one here now, you know, basically it's a rechargeable battery. So now you can kind of see where I'm going with, you know, your mind and your creativity will be kind of the guide of, you know, how long and how much, you know, we can use power sources, for example, to back up, you know, when we have a power outage. You take something like this, again, we already know what's going on here. We'll just take these two batteries out, for example, all right? Put that clip over here. And again, we've got red for positive, or black, excuse me, for negative, right? Let's take those batteries, let's put them over there. And again, you can see something like this. Let's go there, where we'll hook up red onto there, black onto black. Let's test her out, right? Pull the plug. It's still running, right? And again, so it's that simple. And for these ones here, so you buy 2 of them, for example, and you can use one that's being charged and have it ready to go, and just keep one plugged in. And then every 8 hours, you can swap them out, kind of thing, right? You know, when you look at it, that's where it's really kind of interesting, because you take something like this, so now you have the rechargeable aspect of it. So we've got a battery here now. It can be basically recharged. Well, now we have something like a solar panel that does the charging. So when you look at it, what changes? Right? What do you have to do to have this solar panel charge this battery? Well, see, that's where it gets back into this junction box. All that we have to do to make that happen is basically double up our source here, right? You take a solar panel, and again, with the solar panel, you'll have a red and a black, and those red and black will be included into here, so it's basically going to be charging your battery. Now the thing about it, when you have these batteries, they come with their own kind of wires as well, and so you no longer kind of need these, you know, these alligator clips. So give me a second. What I'll do is I'll kind of get those, put those on, and so you can kind of see how the end solution would look like. Okay. So I got the parts. Now when you look at it, here's the end, for example, of your solar panel. You got your black, you've got your red, and they've got this little slip union, right, for basically disconnecting it. So what we would do is we would take your black and red here, right, and then we have our wiring kit, right, which comes to the battery or with the battery, and again, red and black. So we're going to take our red and black ends, for example, and all we're going to do is match them up. So we're going to have 2 blacks, 2 reds, and what we're going to do is basically take that junction box, disconnect, we have, you know, the alligator clips. We're going to put these in there. So let's do that, and that way you kind of can see what I'm doing here. Screwdriver. Okay. So first thing that I'm going to do, I'm going to take the alligator clips off. We don't have any power coming through there. And what I'm going to do is I'm going to drop the power from the safety connector. That way we don't have any power there. So now basically, I've got a junction box here. So all I'm going to do is loosen up. Put those over here. And now we'll take, again, the two reds, tie them together. We'll put both reds in the red socket per se. Then after we have this red socket wired in, all we'll do is we will take the black one and do the same thing. Now that we got the black one tightened down, we can see, again, very similar to the way it was before, only now we have two reds and two blacks. And again, when you look at it, connecting them here is relatively simple. We're going to take our SLA battery, and basically we have our red lead and our black lead. So let's connect red to red, black to black. Again, we can see we got power already over there. All right, as far as the solar panel goes, now all I have to do is take the end of the solar panel, plug it in, and what happens with a solar panel, right, your solar panel now is going to provide juice to your battery. Your battery is rechargeable, and so therefore whatever, again, is basically being provided to the pump is going to be made up with the solar panel. Now, as far as what is needed, as far as solar panels go, you know, the size of solar panel for the 6095, for example, you need about a 14-watt solar panel. Give you an example, this is a 7-watt, but a 14-watt solar panel will power this pump and keep it going forever, right? And that's one of the cool things, meaning like this is where that, you know, hey, how much do you want to do with solar panels, and, you know, as it relates to your, you know, your tank, for example. Because to me, especially with like LED lighting now, and we know it doesn't draw that many watts, for example. So this is where wattage is going to be real important for me as far as being able to grow corals at the least amount of wattage possible. Because what I want to do is basically build kind of a solar panel complex, we'll say. So not only does it power the pumps, but it also powers, excuse me, the lights, and to have it kind of in that perpetual state, not for, you know, 2 hours, 4 hours, etc., but now something that's going to go for days, weeks for lighting and circulation. So again, that's my goal. Eventually I'll get there. For now though, we'll just kind of stick to the pumps. But you look at this and you say, okay, again, it's kind of a DIY thing, but as you've seen here, it's not that complicated. You make sure that red's on red, right? And other than that, it all just kind of goes for you. Now, as far as getting these kind of things, you do a search, for example, on eBay, on Google, on Amazon, and you'll find tons of solar panels. Freight Harbor, for example, they have solar panels. Lowe's has solar panels. I mean, everybody has solar panels. You know, the cost for them, it depends on, you know, again, how much wattage we're putting out. Again, for this particular one, for a 14 watt, I believe the price is somewhere between 70-ish and 80, something like that, to basically power this pump continuously. So again, you got your solar panel, and in there will be a regulator, and you'll want that regulator, right, just because you don't want to overcharge this battery, right? If things are off, you know, in the way of charging, that sort of thing, that regulator will, you know, again, make sure that it'll keep you honest. But again, from a cost perspective, what do you got? $70 there, you know, again, $55 in the safety connector. You got some wires here, you know, your battery, again, depending on your battery. This is an 8 amp hour. They have, you know, all the way up to 32, right? So yeah, it depends on the size, but you can get something like this for 45, 50 bucks. So you can see here now, again, with my goal of being able to get, you know, what I had with the Ecotech, right? Only better. this provides that to me. Because with the backup source on, you know, the Ecotech, the thing about it is I didn't have this perpetual kind of powering option. It was basically, you know, so many hours and it would run out. And I'm sure there are some DIY things that we could do there, but it wasn't kind of set up as easy as this. So that's one of the reasons why I kind of like this. Now, Nico, with that said, I've got power to this unit. Now I think the next step for us is let's take some time now and let me show you how to program these things, what it looks like, right? Basically how it functions and one of the reasons why I like it. Now to program these controllers, remember as far as the controller goes, you have a USB cable. All you do is you're going to take it, plug it into your controller. The other end goes onto the back of your computer. You load some software, which we're all used to by now. And then from there, what you're going to do is you're basically going to plug in the pumps, right? When you plug these pumps, basically you've got it in channels 1, 2, 3, 4. Again. 1, 2, 3, 4. So right now I've got one pump in 1, for example. And you'll see when we open up the software to program this thing, that channel 1, 2, 3, 4 will become important. So let me head on over to the computer, right? And now let me kind of show you how it works, how it functions. And basically let's get this thing kind of programmed so I can actually put it on my main display. And the first thing that you'll notice about this solution is it's a lot different than the Ecotech kind of programming. Meaning that with the Ecotech programming, what you do is you do most of the programming at the controller itself. Whereas with the 7096, what you'll end up doing is setting your parameters of how you want the pumps to behave. And then what you do is you actually send it to the unit itself. Now remember my goal in this whole exercise, meaning I wanted to take a step forward. I didn't want to lose any functionality, and I actually wanted to gain more functionality. Well, this is one area that I'm starting to gain functionality, meaning with the, you know, the Ecotech, the EcoSmart kind of controllers. I found it too confusing to remember the various key combinations, color combinations, etc. To actually program the controller. So I didn't end up using the controller for what it was meant to be. It was kind of a set it forget it on, you know, maybe a reef crest mode or something like that, and every now and then I would change it, but it was just too difficult to program. So for me, I hardly programmed it. Whereas now, what this program is going to allow me to do is I can easily see the numbers of what I want, right, and how I want it to behave. So basically I can set it, you know, I can record that basically profile, and then I can save it here, and then I can change it up basically anytime I want to with this particular program. Or I can do the typical set it and forget it. And in either way, it's a lot easier for me to do that programming, which I like. Now, with that being said, I do know that Ecotech is coming out with, you know, their whole cloud offering where you'll be able to basically use their graphical interface that they have on the cloud to basically program the pumps themselves, just like they do with the lights. And again, though that, you know, that's kind of cool that they finally got there, the problem to me with that is, hey, I've got a Neptune Apex because I want to control, you know, pH, and I want everything all integrated, right? So that way there, if the power goes out, you know, my Neptune says, hey, I know the power's out, so what I'm going to do is I'm going to change my pumps to a certain way, right? And same with the lights and all that sort of thing. So that integrated approach is the way that, you know, I want to control my pumps, lights, and everything else. And so I'm going to go the Apex route, and, you know, so therefore the Vortec kind of option really isn't that appealing to me of doing it through the cloud. And with that being said, you know, the other thing that I really like to do is I like to control it from my, from my iPhone, for example. And whether I have internet or I have local network capabilities or from my controller, if I use that Neptune as my kind of central repository, again, it's kind of one-stop shopping. So it's like a chain. I have less links that will break, easy for me. So as it gets back to controlling the units itself, I like the fact that we can control it locally with this software product, which again will run on a Mac or a Windows platform. And again, it also gives me the ability to control it through my Neptune Apex and through kind of the whole, Neptune cloud offerings as well. So let's start by actually reviewing the interface of the software program. And when you look at it, basically you'll notice there are kind of 5 grayed out sections here. If you look at the name of in the top left-hand corner, it'll tell us what that section controls, right? So from mode to options to data, for example. So let me take a second now and review basically each section and how they work. Let's start first by looking at the mode section. Now when you look at the mode section, when you select the mode that you want, you'll notice that over here in the middle, it'll tell you the mode that you've selected. Now one thing to notice on the actual icons themselves are the little graphics right below it. So pulse, for example, you see kind of a big arrow and a small arrow. When you look at the interval, you see your arrows, but then there's space between them. And then when you see sequential, you'll see 1 arrow, 2 arrows, 3 arrows, 4 arrows. Well, those arrows really kind of give you a clue as to what's happening in that mode. For example, pulsing means basically you have 2 sets or 2 variables of the speeds that you want. You can maybe a high and a low, or a higher and a lower, or 2 highs or 2 lows, or whatever you want. But ultimately, it's going to give us that kind of option to select 2 speeds of a pump. When you look at intervals, what it's going to do is it's going to be combined with the pulse. So you'll be able to control 2 speeds, but then you can also control basically 2 sets of pumps. And I'll go over that in a little bit here on the controller side. But think of it as having 2 sets of pumps that will give you the ability to control the pulses on each set differently. And then lastly, we have sequential over here, which basically, if you look at the little graphic, kind of tells you what's going on, meaning the first pump's going to kick on, then the second pump, then the third pump, and then the 4th pump, right? So that it starts off with 1 running and then they end up with all 4. And again, that's for maybe something like, you can create surges. You can do all kind of really cool things with that kind of idea. But the idea to be able to manipulate pumps in a sequential fashion is how this sequential mode is going to work. Now remember, the mode over here is tied into the power control. So let's talk about the power control and what this section is. First of all, we have a pulse flow. So the pulse flow is how long is that pulse of the spinning around of the propeller going to take place. Then second, you have it says the power section over here, but think of this as speeds, right? So in other words, speed 2, speed 1. And then vertically, you can see we have basically channels 1, 2, 3, 4, or pump 1, 2, 3, 4. So these basically correspond to the sockets at which you plug in the pumps. Now you may have noticed when you select a mode, basically the power control settings change a little bit. So let me talk about that correlation. Basically, when you select pulse, for example, what it's going to do is it's going to treat every one of these pumps, pumps 1, 2, 3, 4, as kind of independent. Meaning, you're going to set whatever 2 values you're going to have here for speed 1 and speed 2. And it's going to control it continuously at those particular speeds. And it's going to do that pulsing at a rate of this 0.03, or excuse me, 0.3, or whatever you put into this box over here. And so, for example, to get any one of those waves that you may see on the EcoVortec pump, like the commercials and that sort of thing, basically you need 1 pump, and you set it to a 0 and 100, and you set the kind of pulse flow, and it'll give you that, again, that rocking wave that you always see, and really was one of the first ones to do it, right? But again, the joy of this controller here is you can do that any way you want with 4 independent pumps. And that means, for example, if your pump 2, if you wanted to do it lower in the tank, for example, by maybe fleshier corals, like your LPS or your softies or your mushrooms, you could do that to control, the surge a lot less, or the pulses a lot less. Maybe to a, maybe a 40 at the low end and a 70 at the high end. But either way, it allows you to independently control those. Now, when we go to the interval setting, right, you'll see, number one, the little graphics down below that you kind of see where it means by interval. But you'll also see over here on the left-hand side, it put this bar right in the middle. So now what that means is basically you've got intervals between this set of pumps and this set of pumps. And those time intervals are going to be controlled by this interval time up here. So let's just take, for example, the scenario of maybe what we wanted out of pump 1 is to do the normal kind of, pulsating, surge, wavy kind of flow rate. And then for maybe pump 3, for example, what I wanted to do is I wanted to give it, 100% blast everything off those corals that I could. And what I wanted to do is I wanted to do the pulse, say, for 5 minutes. And then for the other 5 minutes, I wanted to surge, or I wanted to blast everything off with everything running at 100%. Well, this is how we would do it, right? So it allows you to group pumps together to basically have them behave differently or with their own set of characteristics for this time interval. And again, when you look at the interval icon with the graphics below, it kind of gives you that idea. Same with the pulsing. You can see, again, 2 different size pulses. And again, you can have a big pulse and small, or you can have all high. It's really up to you. But those little graphics are meant to kind of give you an idea of what's going on there. Now let's take a look at sequential. Now with sequential, as you can see by the little graphics, the idea is to basically have 1 pump, 2 pumps, 3 pumps, 4 pumps kicking on at a certain time. Well, that time here is controlled by this value up here. So if we wanted to kind of mimic that Carlson surge device, well, all we would do is kick this pump on, right, at 100. Then we'd take this pump, right, same thing, jack it to 100. 3rd pump, jack it to 100. And then finally the 4th pump. So what would happen is sequentially every 10 seconds we would be adding circulation to the point where ultimately by the time, all 4 were kicking, we had a ton of flow. And then again, it would drop back down to the 1 pump. Now the interesting part about here is you can do the exact same thing, for example, with that pulsating, right? Or you can take, and instead of creating that massive surge, maybe what you do is you create a massive pulse, right? And you can control that differently. But either way, you can see how independently you can control these pumps by this amount of time. And so basically that's the correlation between this mode section over here and the power control section over here. And really the options of being able to control and get the flow that you want with the 4 separate pumps is pretty large, right? It's not 5, 7, 10. I mean, you can do all kinds of options here based on the flow patterns that you would like. Now let's take a look at the options section, or I like to consider these events. Number 1, going through here, you will see 4 different kind of events that you will have. First one, food timer. It's kind of self-explanatory, meaning when you hit the food button, the pumps will be off for this amount of minutes. Now the moonlight and the night mode kind of go hand in hand, meaning that there's a little photo sensor that basically when the lights are shut off, a little moonlight will glow on here. Now that coupled with the night mode basically says that when that little photo sensor hits, right, when the lights are turned off, then we'll basically operate your pumps
in an idle fashion. There's all kind of different mixtures that you'll get depending on whether you're set in pulse mode, in interval mode. But the idea ultimately is to kick it down, right? Just like on the natural waves of the ocean, for example. And then, speaking of the natural waves of the ocean, we have the storm cycle. So the storm cycle basically is going to create like a random chaotic kind of pattern for 5 minutes, right, for the pumps that you have plugged in. You know, this many times in an hour or in a day, meaning if we have it set to once, it'll occur once an hour. If you have it over here, once a day, right? So it'll depend on what you put in there as to, you know, when the storm cycle actually kicks. So if we look over here at the wave controller section, basically if this box is checked, it's going to take sockets 3 and 4, and it's going to do that pulsating. And the really cool thing about this particular section is you can do the auto adjust, meaning when you click start, you can actually watch your wave for that pattern. And then when it gets to the type of wave that you want, all that you actually do is select stop, right? And from that point on, that will basically freeze that kind of wave that you had. Now it's mostly, you know, pretty accurate. You might have to knock it back, right, to, you know, a 1/10 or 1/100, excuse me, of the seconds, depending on, you know, how late or early you catch it within kind of that pulse. But again, it's a good idea when you have kind of shorter tanks or longer tanks to use this to figure out roughly what kind of pulse you need to get the wave that you're looking for. So another cool feature is this inverse. When you look at it, notice the numbers up here, they actually inverse. So the idea is when 3 is idle, 4 is pulsating. When pump 3 is pulsating, 4 is idle. Right? Again, just another pre-programmed kind of feature that lets this kind of, we'll say, you know, wave control in autopilot mode. Gives you ability to, again, to control that differently, to get different patterns without a whole lot of tinkering up here in the power control section. Lastly, we have the data section. And it's called that because once you have this data programmed, you got to send it somewhere. So the idea is we can use this option here, record to a data file. Basically means to save it for a file or to a file. So that way there, in the future, we have a record of it and we can use it as backup. So we can create different patterns and easily apply them by just kind of, again, restoring from that data file. And then ultimately, once you kind of get the data here that you like it, basically you send it to the unit or you receive it from the unit. So it's basically where do you take that program, right? And, you know, and this is one of those features, again, from a controller perspective, right? Remember, you're going to have some sort of computer plugged into this controller to program it. And this is how you'll do that, right? You'll send it to there, then after you program it, then you plug it back into your pumps and you're operating basically as this particular program has been defined.
From a programming in, when you're done, basically you just unplug the USB cable from your controller or a little computer, right? And from there, it kind of works. And you can kind of see here one of the reasons why I like it so much, meaning I'm a visual guy, right? For those of you who don't need numbers and things of that nature, then maybe this isn't the solution for you. But for me, I love it because I can see it, I understand it, and it's relatively easy, right? We're kind of, coming to that point where we need to wrap this up a little bit, but I did want to make note to one thing. Again, the noise here. As you can see, I've been demoing these kind of, how-tos and stuff like that, and the whole time, this, you can hardly hear it. And that's very important to me. Now, again, you know, it's one of those things where 16 months from now, we're going to come back and we're going to see how these things really sound, right? If they're as quiet as they are now. Now, I've had them before, and I know the answer is going to be yes, but, you know, it's one of those things where we'll make sure, right? We'll circle back and we'll see, again, what kind of noise that these things provide in that tank. And, you know, ultimately, that will be my utopian, right? Because I wanted to get what I had with the Vortex, only and then some. It'll be much quieter. Again, a lot more backup options and power, better flow, better control. So again, my definition of that perfect mousetrap. Now, you know, I've heard me say this many, many times, but, you know, give our sponsors a chance to earn your business. Tunze in this example, right? Well, when you look at it, you know, it's because of their efforts to create products like these that will help us not lose our reef tank and still be a successful reef hobbyist, right? You know, for those of you who have lost your tank, right, it's not pretty, right? You know, it takes forever, 5, 10 years, for example, to grow corals out. And, you know, because of something stupid, for example, or something that could have been prevented, you know, I mean, why not invest in something like this? So it's their engineering that will make these kind of, you know, options available to us. And I think, you know, for a company like Tunze, who offers 2 years support on everything that they got, you know, I think, you know, those are the kind of manufacturers in this hobby that we want to support. Again, on those lines, where can you get the Tunze products? Bulk Reef Supply, you know, Premium Aquatics, for example. Again, two great online companies that, again, deserve that chance to earn your business because they're looking to make sure that A, you become a successful hobbyist, say that 10 times, successful hobbyist, but then B, at the same time, you're not doing it by breaking the bank. So again, give these guys a chance to earn your business. Again, I am Russ Kickle. Stay tuned for another episode of